Hello dear students, welcome you all. Well, today we are going to start solving section V of your question paper. You can see here the question paper of statistical and thermal physics. Now we have already solved section A. I'm coming to section V. In section V, there were three questions. You have to attempt any two questions, right? The first question, that is question number 2, was using Maxwell law of distribution of molecular speeds, drive expression for average speed, root mean square speed, and most probable speed. So, first of all, we have to understand what was asked in the exam. Many students have tried to drive the Maxwell's Boltzmann distribution law. Then after they have derived these expressions. So I can say they have wasted the time in driving Maxwell-Boltzmann distribution law because it was not asked in the exam. I have simply asked you uh, by using Maxwell-Boltzmann distribution law. This is clear, right? Of molecular speeds. You have to drive the expression, only expression for average speed, RMS speed, and molecular speed. I have told you in the class also that it is very important to attempt the question paper according to the questions because the questions are designed as per the time limit of the exam. So there is no need to go for driving all these expressions. Examiner know all these things, right? So today we will drive these three expressions by using Maxwell-Boltzmann distribution law of molecular speeds, right? So we will start with first of all Maxwell-Boltzmann distribution law, right? We know the expression for what is the expression for Maxwell-Boltzmann distribution law. It is NB dV is equal to 4 pi n into m upon 2 pi kt power 3 by 2 into b square into e raised to power minus mb square upon 2 kt into the whole term into dB. This is the expression that we have to use for driving the expression for average speed, RMS speed, and most probable speed, right? So you can see here, what is the, first of all, we have to understand what is the meaning of this distribution law. This law is actually telling us the number of gas molecules n that has the speed between the limits v to b plus dv, right? This is giving us this limit, this number in this limit, right? And this is the right hand side give us the expression, and it tell us on what factors this number depend, right? So we will start with average speed, right? So first of all we will drive the expression for average speed, right? We'll start with average speed. Average speed, clear? So if we go to the average speed, what is the meaning of average speed? Average speed simply means that the average of the speed of all the gas molecules, right? So what we have to do first of all we have to find the sum of the speeds of all the gas molecules and then divide that number by the total number of gas molecules, and if I express it in the mathematical form, then I can say uh, you can write it in this way: V average is equal to summation of ni vi divided by summation of ni, right? Here this in the denominator it is giving us the sum of the speeds of all gas molecules. Denominator is the sum of all the total number of gas molecules, right? So now we can use it, uh, we can convert this expression into integral here, right? In place of this, now I can write here is equal to is equal to integration of b n b dv divided by 0 to infinity n b dv, right? And this term here v b and v dv, right? uh, I have converted this expression simply into integral form. The limit here is infinity and it is 0. It is from 0 to infinity b nvdv divided by nvdv, right? So this nvdv in the denominator, it will be simply what? It is equal to n, small n, total number of the gas molecules in this range, right? Now we have taken the range 0 to infinity. We have considered all the gas molecules with their speed limit from 0 to infinity. The same thing is here. Because there will be no molecule that will have the speed infinity. So there is nothing wrong in considering the upper limit as infinity, right? So when I further solve this expression, it will become it will become 1 upon n b average is equal to 1 upon n integration 0 to infinity b into nbdb, right? This clear? So now the next task is to put the value of nbdb in this expression. Now we know nbdb is given here, right? So you can put this value here. When you will put this value here, what you will get? Uh, Simply this n will get cancelled from this n. One thing is there. You will be left with nvdv. When I put it here, b average will be equal to this expression 4 pi m upon 2 pi kt power 3 by 2, and here we will get the integral b will get multiplied to this. Clear? Can you use the eraser? Now you will get b average is equal to, here it will become b cube. Clear? It will become b cube, and it will be the integration 0 to infinity, because all these terms they are or that are outside the bracket, they are constant. Here it is not no more. Clear? Now we are left only with the 4 pi. Clear? Right. Now we have this expression 4 pi m upon 2 pi kt power 3 by 2 integral 0 to infinity b cube e raised to power minus mb square upon, here it is minus mb square upon 2 kt into dv. Now here we are going to use the standard integral. The standard integral is, I have told you in the class also, it is 0 to infinity, and you can write here x cube e raised to power minus a x square. So it is equal to 1 upon 2a square. So this is standard integral that we are going to use in this expression here. Clear? So what is x here? X is v. Clear? X is v here. It is given here. What is a? A is minus m upon, not minus, but it is m upon 2kt. M upon 2kt. So obviously then we will get what? We will put the value here. when we will put the value, you will get simply, you will get 4 pi m upon 2 pi k t, it is 4 pi power 3 by 2 into 1 upon m upon 2kt whole term square, or it was 2 outside. Clear? So this is what this expression is what it is, 1 upon 2a square. A was m upon 2 pi kt. uh, yes, 2 kt, not 2 pi kt, but it was 2 kt. Clear? So when you will simplify this expression, you will take the square of it and it will multiply it, you will get b average is equal to 8, you can use it, 8 kt upon pi m power 1 by 2. So this is the expression for a B average, 8 kt upon, here k is Boltzmann constant. In books it can be written here kv, so it is understood it is Boltzmann constant. So this is the expression for a average speed, right? Now I'm going to the next, that is expression for a root mean square speed. Clear? So what is the meaning of RMS speed? First of all, we have to understand RMS speed, root mean square. Root mean square means it is understood, it is the uh, root of the square of the mean of all the speeds. Root mean square, BRMS, right? So we can express it in mathematical form, BRMS square, that is equal to summation of NI BI whole square divided by summation of NI. Now what is here? This is the sum of the square of the velocities of all the gas molecules, right? Because it is written here root mean square, and when we are dividing this sum by the total number of gas molecules, that is summation of Ni, it will become mean of the square of the velocity of all the gas molecules. Root, automatically when we will take this square toward this side, it will become root, right? So in that case you will be left with the uh, BRMS. Clear? But to drive this expression, first of all, we have to solve this, and then after BRMS square, then after we can further take the under root. So again, now NIVI square. Clear? So again, if I convert it into the integral form, then it will become integration 0 to infinity b square n b d b divided by summation of 0 to infinity n b d b. Clear? So same thing is here, 1 upon n integration 0 to infinity b square n b dB. Clear? So n comes from here. Same in the case of average speed, and this term is b square nb dB. Clear? So again, what we have to do? We have to put the value of nb dB here. So when you will put the value of nb dB, it will become 1 upon n integral 0 to infinity 4 pi m upon 2 pi k t power 3 by 2 b power 4 mm, into into e raised to power into e raised to power minus mb square upon 2 kt into db, right? So this is the expression here. Now after solving this expression, we will arrive at the BRMS. First of all, we have to take 4 pi n was also there. I think I have mistaken. It was also there. N, right? So n will get cancelled from this n. Clear? When you will take it further, uh, the terms that are constant, they can be taken outside. Now here it is 4 pi. We are left with 4 pi only. No, no. Now integration will go there, 0 to infinity. Clear? So we have now this integral b power 4, right? E raised to power minus mb square upon 2 kt into dv. So again, this is a standard integral. Clear? This is a standard integral. I can write it here. Standard integral, that is integration 0 to infinity x power 4 e raised to power minus x square minus ax square, that is equal to 3 by 8 a square into pi by a power 1 by 2. So again, if you look at this expression, x power 4, x means what? B. Clear? So a minus ax square. Clear? So what is a? Again, m upon 2 kt. A is equal to m upon 2 kt. Clear? So we can put a here, a square here, and then after putting it, we will get the final expression. Clear? So when you will put it here, I'm going to put it in this equation. Right? B RMS square is equal to 4 pi bracket m upon 2 pi kt power 3 by 2 into 3 by 8 bracket a square m upon 2 kt square bracket pi by a m upon 2 kt. Clear? Power 1 by 2. So this is what was the standard integral? 3 by 8 a square into pi by a. So when you will solve this expression, if you don't want to go for solving this expression in the examination, you can even directly arrive at the value that this value will come out to be 3 kt upon m. 3 kt upon m. What is it? BRMS square. So what you will get? 3 kt upon m under the root. This is the BRMS. Clear? Root means square value. Root means square speed. BRMS is equal to 3 kt upon m. This is the expression for a BRMS. Clear? now we are going further. We are going to calculate the most probable speed. Clear? The third and the last one. So for that, most probable speed, most probable speed, B most probable. Clear? So what is the meaning of most probable? Most probable speed means that that value of the speed that is uh, shown by the maximum gas molecules. That is most probable. Clear? So to find out the value of the most probable speed of the gas molecule, we can use the mathematical relation d upon dv p v b is equal to b most probable, that must be equal to 0. Why I use this? Because when the probability, we are actually what is PV? PV is the probability of the existence of that speed, and what speed? B is equal to B most probable, means most probable speed. Clear? The probability of that speed will be maximum and it will be stable. So when we will take the derivative of d, this expression with respect to v, d upon dv, it should be equal to 0. So simply what we have to do, we know what is PV. PV is what? PV is, we have seen it in the case of Maxwell-Boltzmann distribution law of molecular speeds. So I can write the value of PV. Okay. We know NBdV is equal to 4 pi n m upon 2 pi kt power 3 by 2 b square e raised to power minus m b square upon 2 kt into dv. Right? This is NVDV, 4 pi n m upon 2 pi kt power 3 by 2 b square e raised to power minus mb square upon 2 kt into dv. Clear? Now, it is very important, if I took this n toward this side, clear? Then what it will become? NVdV upon n. Now, what is this? NVdV upon n. It is basically giving us the probability of the existence of the speed v. How? Because NVdV is the number of gas molecules that has velocity in the range of b to b plus dv. And when I divide it by n, it will give us the number, that how much gas molecule possess this range of velocity. It means it is probability, basically PV. So I can say this is PV. So PV is what? Right here. Four pi. PV is equal to 4 pi m upon 2 pi kt power 3 by 2 b square e raised to power m b square upon 2 kt. Now what we have to do? We have to take the derivative with respect to b. Clear? You can take the derivative. D upon dv, and that should be equal to 0. Clear? So when you take the derivative of this expression, provided b is equal to b most probable. Clear? This is the condition. You can apply this condition here at b is equal to b m b. Clear? So when you will take the differentiation, again those terms which are constant, they can be taken outside. So you can take 4 pi m upon 2 pi kt power 3 by 2, and then d upon dv b square e raised to power minus m b square upon 2 kt. Clear? And this b P is equal to B M P, that should be equal to 0. Now we have to do the differentiation of this. And how we can do the differentiation? We can do the differentiation by applying the product rule. Clear? Of the differentiation, because there are two variables, b square and e raised to power minus mb square upon 2 kt. So I'm hopeful that you can do this differentiation at this level. So when you will do the differentiation, you will get the expression after solving. You will get it. You will get b most probable is equal to 2 kt upon m under the root. Clear? So now this is the expression that we will get after solving this equation. Clear? This differential and then equating it to equal to 0. Clear? So this is the expression for b most probable. Now we have derived expression for all the three velocities, that speeds that were asked in the question paper. Root mean square speed, clear, average speed, and most probable speed. So what are the expressions? The last one was b most probable. It was 2 kt upon m under the root. Then we have b rms, that is equal to under root of 3 kt upon m. Or then the next is b average, that is equal to 8 kt upon pi m. So these are the expressions for all these three speeds that were asked in the examination. And you have to derive only the expression. I have only asked you to derive the three expressions, right? So this is the answer. I have not asked you to compare which velocity is higher, which is lower. So that was not asked here. You have to only ask to derive these three expressions. So this is all about it, right? So this was the answer to this question, and it was of 5 marks. So now I'm going to the next question in next lecture. So till then, thank you.